In today's note, we're going to be looking at bias and how we can come across bias with the types of sampling we do or in our surveys. So again, before we start into bias, let's take a little bit of a look at some of the stuff from our previous notes. So in the table below, or the table here, it shows the number of Canadian men who play in Division 1 in the NCAA basketball. The first thing we want to do is classify the variable that we're looking at and decide on an appropriate graph to display the data. So if we're looking at this, we are looking at the number of players per year. So the variable that we're looking at is the number of players. So we are dealing with the numerical data, and it would be discrete because there is only a set amount of players, or it is a fixed number of players that we can have. Right? So we're not going to have a range of players in terms of like decimal numbers. It's going to be a fixed number, like 1, 2, 3, 4. In this case, 80. It's not going to be 80.35, etc. So because this is numerical and discrete, we would want to display this as a bar graph. So the next thing is this micro data or aggregate data? So because we're not seeing the individual data responses or the individual school data, we're looking at the overall number of all the schools added up. We would be looking at aggregate data because we're looking at the group. We're not looking at the individual. Right? So in this case, the individual would be the school, and we're not looking at each individual school. So what trend do you know? Overall trend do you notice? So overall, you could say it is increasing, or you could say it increases, then decreases, then increases again. Because you see 80 drops to 70, jumps back up to 80, goes up to 895, drops back down to 88, goes back up to 105. So you could say it fluctuates, increases and decreases and increases. You could say overall it's increasing. And then D, what number of players would you predict in the 2014-2015 season? Again, depends on what the trend you think it is. You could argue that it's going to keep on increasing. So you could say something like, maybe there'll be 110 players, or if you argue that it increases and decreases in a kind of a periodic fashion, you could argue that it would drop back down to, say, maybe 90 players. And then you could say the year after that, it would jump back up. So it all depends on how you want to look at it or what you believe the overall trend is. And in this case, you could argue for either or. So what is statistical bias and why does it matter? Well, a statistical bias is any factor that favors certain outcomes or responses and therefore skews the results. So if we're looking at our surveys, basically anything that can change or persuade the outcome of our survey. And we're going to look at different ways that can happen. So the types of bias that we could have. We could have one, sampling bias. And sampling bias is where the sampling does not represent the characteristics of the population. So this is where whatever sample you collect, it does not accurately represent the population. And this would be the result of problems with the sampling techniques, which we've learned in other notes, or data collection. So just how you're collecting the data. Non-response bias. So this is where particular groups are underrepresented in a survey because they choose not to participate. So whether it's a lack of interest or whatnot, you're not getting a response from certain groups. And the researcher has to ensure that the sampling process is truly random. Right? Because if you're not getting responses from particular groups, or certain groups are not being represented, then that has to deal with the sampling or the sampling process. The other type, response bias. So this is where participants deliberately give false or misleading answers, or they may want to intentionally alter results, or may be afraid or embarrassed to answer sensitive questions honestly. Right? So the response bias comes from the actual answers that are being given. So this is where maybe students are trying, or maybe subjects are trying to fit in, and they want to give answers that they feel other people would give. They don't want to answer them honestly and whatnot. And finally, measurement bias. So this is where the data collection consistently under or over represents a certain characteristic of the population. And the main thing where we could get this is based on how the question is being worded. So usually this means that there's a lot of leading questions, basically questions that lead a respondent or lead a person to a certain answer, or loaded questions that contain wording or information that influences the response. Right? So just being careful on how you word the question can definitely impact how people will answer the question. So if you go to student.desmos.com and enter this class code, you should be able to look at a card matching activity where you can match up various scenarios to the type of bias or type of sampling bias that is occurring. And when you do that, I want you to think about how you can change each situation so that the bias is eliminated. Once you've done that, the other thing we can look at is in addition to avoiding bias, you have to evaluate the validity of research sources. So aside from looking at or how we ask or survey specific things, we have to look at avoiding bias with our research or with secondary data. Right? So for example, if you're looking at, say, something like Statistics Canada, you could argue that that's pretty it's a fairly valid source of information, but again, not all information you look up or all research or all data you get is going to come from Statistics Canada, right? If you're looking up specific information maybe about certain video games or certain sports or certain things that interest you or companies, you may want to look elsewhere. But when you do, you have to look at kind of four things. And you can use the acronym CARS to help you sort that out. So the first thing is credibility. Is the source reputable? So is the source where you're finding this information reputable, or is it some random website that someone created on their own and threw up information? Right? Accuracy. Are the graphs misleading? So you want to look at are the scales correct? Is there anything that they've done differently? And we'll look at some examples that could mislead the average person or the quick viewer into a different opinion. Reasonableness. You want to put the numbers into perspective. So sometimes they may throw up numbers and they may try to use those numbers to sway you one way or the other, but you have to put them into perspective and say, okay, is this reasonable considering what we're looking at? Support. So how was the claim substantiated? So do they have enough support to show that their claim is correct? And another thing you can look at with this is, again, the sampling techniques. Right, again, how did they collect their data? right? How do they collect their research, right? Can their claims be substantiated? Is there any bias in how they've collected or tried to support their inference? So looking at some misleading graphs, we can see here, these are two graphs showing the number or the days of freezing temperatures in 2007, 2008. While both graphs show the same information, one graph we can see clearly only shows from 80 to 85, while the other one shows us from 0 to 100. While we're still showing the same information, we can see that clearly there's a large difference between 2007, 2008 in the first graph, where in the second graph, it doesn't look like there's much of a difference at all. So again, there's nothing wrong with the data, it's just how it's being represented, right? So the accuracy of what we're seeing is not quite there. So we have to be careful when looking at graphs like this. You want to really take your time to analyze them. So if we look at a couple graphs, just to take a look and see if there's any bias and see if they're valid or not. So one thing you want to look at is our source, Reuters Institute for the Study of Journalism. Okay, you could argue that that's a fairly reputable source. It's not just a random place online. If you look at your scales tend to be going up from 0 up by 5, so we are seeing the full view of everything. The bars seem to be accurate. What we're looking for is 1 in 4 Americans use a smartphone to access online news. So we're looking at different countries. So you could argue that 1 in 4, we don't really see any, we see a percentage, but we don't really know what that percentage, or sorry, it says percent of population. Yep. So okay, 1 in 4, 28%, you could argue is close to 25. So yeah, that would be 1 in 4. We see tablet information, that's fine. We see when the research was conducted. So it was conducted really only over a short period of time, which may have impacted it. Again, you could argue, well, we're looking at all these countries. You could argue, where's Canada? But again, you could argue that this is valid. If we look at the next graph where we're looking at Google's annual advertising revenue, and we want to see Google's ad revenue over newspaper ad revenue, so how much money they make off of advertisement. So looking at this, we don't quite see a label, but we can kind of inference that this means year. We can look at how the source is looking at Google itself. So we are looking at, again, Google's looking at information, or getting our information from Google and from newspapers. It doesn't really say which newspapers. So that could be an area of bias. Again, talking about how the newspaper revenue is kind of come up. Again, your argument on whether or not is up to you. Revenue in billions. So here, from 0 to 10 billion is a pretty big jump in terms of what we're actually looking at. So the scale can be hard to tell, right? So it's hard to tell really what the numbers are, because again, we're dealing with large numbers, but it is a large jump. So you could argue that the scale makes it hard to really see which, what the actual values are. So again, it's just taking a look at all these different things to make sure if it's valid or not. If we look at another one, just taking some time to look at the graph. So here we can see that the numbers are actually increasing from the top down. So while it looks like things are actually decreasing after the stand your ground law was enacted. It's actually increasing, but the way the graph is shown, it doesn't really show that. Definitely highlighting the top part makes it look like it's decreasing. So again, just some accuracy with the graphs. Looking at a picture or a screenshot from a news report on TV. So again, while it looks like a lot of Americans today have tried marijuana compared to last year and the year before, but if you look at all of the actual values, 51, 43, and 34%, those numbers don't add up, right? The source, MOE, I'm not really sure what the source is, or sorry, margin of error is 4%, but again, it still takes us way over. Look at another one. How concerned are you about the Zika virus? So again, clearly here, we're seeing the scales not really add up. So it looks like not many people are worried at all if you're just looking at the bars or if you just happen to quickly look. However, clearly the percentages don't add up, or they don't make sense in terms of the bars. Finally, over 10 million now receiving federal welfare. So again, it looks like it's a large increase, but again, if you look at the actual values on the side, again, you could argue that it's slowly increasing, so it's not that big of a jump in terms of the years. It seems to be going up. So again, it's just taking a look at everything from the information or all the values, the sources, the sampling techniques and whatnot to really understand if there's any bias to the actual research or the actual inference that you're making.